Welcome. This is Dr. Morton again, and this is another lecture. This is going to be class day 8, and I'm going to talk. I'm actually going to talk a lot about 5, but I'm going to begin the review of chapters 1 through 5. What I want to do in this one is I want to focus on making sure you understand how to take a truth table and write the min-term expression, the max-term expression, the min-term notation, and the max-term notation. You should be able just to do these straight off the truth table without really a whole lot of thought, because it's very straightforward. But the problem is, if you're confused about how to do it, then that's going to make it very difficult for you. You have to have some practice, and you have to have done a few, and then it's like, oh, it's really straightforward. It's really simple, which it is, but this can be a little bit off-putting. Okay, so what I want you, so let's first take a quick look at the truth table, and then we'll talk about, not the truth table, the syllabus. It's kind of the truth table for the course, though. I guess that was my confusion. All right, so here we are on September 9th for this term, and it's read chapter 5, and remember, tomorrow night you need to do the end of chapter 4 quiz, so don't forget to do that. And then, let's see, and then the homework 4 is due September 12th. That's Monday night, I think. So make sure you have plans to get that done. Okay, let's dig in. Okay, so again, here's the, let's see, Okay, here's the text. Now, what we want to do is, so this is chapter 5, and I've already talked about chapter 5 some, and I've been over this, but I want to drill you on it. And basically, this is going to be a relatively short video, and we're just going to practice with some truth tables. All right, so remember, we've been over the learning objectives and the terms, and we've been through here, and we're going to use, So we're going to use this form. Now in this case, notice I don't have an output, but I'm showing you the min term and the max terms for each row. And so we're going to refer back to this if we need to. So let's look at this for a second. So for the first row, remember we have a min term and a max term. Now don't be confused about this. The min term and the max term for each row do not equal each other. They are the inverse. But our min term and max term solutions are equal to each other. And the reason for that is we select min terms for rows where our desired output is 1. Now we don't show the output column in this table. But if we have an output, then that's where we pick these. Where they're 1, we pick the min term, and we OR all those min terms together, and that gives us the min term solution. Picking one where every row where the desired output is 1. When we want to do the max term solution, we pick the max terms from the rows where the desired output is 0, and we AND those, or multiply those together. And the reason that works is because when we multiply these max terms together, we'll get a 1 unless one of those max terms resolves to 0. And the only way that happens is if all of the variables in that term are 0. Because if any of them's 1, then that term will be a 1. It's just the opposite for the min terms. Min terms only give us a 1 when all the variables match. So in this case, like ABC, A has to be 1, B has to be 1, C has to be 1. You AND all those together, and you get a 1. But here, A would have to be a 0, B would have to be a 0, C would have to be a 0 to get A prime, B prime, C prime ANDed together to give you a 1. So if you have a 1 for row 0, you use this term, and you would never use the max term because you look for rows where the output's a 0. Whereas, say, for row 3, 0, 1, 2, 3, right here, if the desired output for this row was a 0, then you wouldn't use the min term, you would take the max term. And the max term would give you the 0. But for rows where you want a 1, the min term is going to give you a 1. And remember, The min terms are and terms, but they're ORed together in our final solution. The max terms are OR terms, but they're ANDed together. And so the max terms deliver zeros, and the min terms deliver 1. And that's how it works. Okay, well anyway. Okay, so now we're gonna look, so we have this truth table here, but I have question marks for f. So we're going to pick just sort of 4 random truth tables, and we're going to pick some different values for f. Now, where do we get f from? Well, remember, I like to say we get f from God, but it comes from our customer. But we want to treat our customer as God, okay? So let me back this up. Here we go. So here's our first truth table. But I did it too much. Let me back up. Yeah. Okay. Now, so here's our first truth table. So we have f is for row 0, it's a 1. For row 1, it's a 1. For row 2, it's a 0. For row 3, it's a 0. For row 4, it's a 1. For row 5, it's a 1. 6 and 7 are both zeros. Now remember, do not forget. This is really an important point. Do not forget that we're only going to take the min terms for rows where f is 1. And we always count rows starting with the first row is 0. So it's the 0th row. And the last row for a 3-variable truth table, they're going to be 8 rows. So the last row is not going to be row 8, it's going to be 7. So always remember, we start with 0, and we're going to have 2 to the n rows where we have n variables. I could just as easily have done this for a 4-variable truth table, but then I would have to have 16 rows. And it gets a little cumbersome to fit 16 rows, and it's just a little, it adds to the confusion, it doesn't simplify it. But a 4-variable truth table is exactly the same thing, okay? And we'll do maybe one, maybe at the end we'll do one, or maybe next week. We're going to, I meant to tell you with the syllabus, let me bring that back up if I can. Yeah. So I meant to tell you with the syllabus that if you look next week, what we're gonna do on the 12th, Monday, is we're gonna do a practice test, and then we're gonna do more review on Wednesday, and then Friday, I'll hopefully do another review lecture, but then we'll give you the ability to take the test from about noon that day until midnight. So anytime from, say, noon to midnight, or about that, something like that, probably about noon to midnight. And it'll be online, and we'll talk about the test some next week. But all we're gonna do next week is review the test, and then on Friday you're gonna do it. Okay. So let's. Oh no, this is still here. We just want to do that. Okay. So now we're gonna go to. Now we're gonna try and work this first problem, and I think for that I'm gonna switch over to paper. All right. So let me see if I can get this right. So the first thing I'm going to do is write down the shorthand notation. Now, if we look at this, we have a min term for row 0, 1, not for 2, not for 3, 4, and 5. So if I do the shorthand notation, and then I'll just work the problem from that. I think that'll be the easiest way to do it. So let me do it. So 0, 1, 4, and 5. Okay, no problem. So now we have the shorthand notation. We'll write f equals the sum of the little m's 0, 1, 4, 5. Now remember, these are just the row numbers where the desired value for f is 1. And that's why we're going to use the min terms from those rows. And each of those min terms is going to give us a 1. Now, how do we write that? So we call this the notation. This is the min term notation. There's also a max term notation. The max term notation would just be f equals the product of the big M's and then we list those. And it's going to be all the ones where we have zeros, which are the rows where we don't have ones. So we have ones in 0, 1, 4, and 5, so that's going to give us zeros for row 2, for row 2, 3, 6, and 7. So that's the min term notation up here, the max term notation down here. So min, max. Now if I talk about the expression, that's different. For the expression, we want to write all this out. All right, so how's that going to look? Well, let's do it. So for the min term expression, f will just equal, we'll have the min term for row 0. Well, what is the min term for row 0? Well, we just looked at that chart. So let's go back here, and then we'll go down with this. We'll go down here. So remember, so they're the min terms for each row for a 3-variable truth table. So for first row, it's A prime, B prime, C. And the reason it is that way is because A is 0, B is 0, C is 0. So we write the primes. Now the max terms, just the opposite. We write non-primes for this first row because they're the max terms, and they're the inverse of the min term. Again, I can't say it enough. The min term solution and the max term solution are not the inverse of each other. They are exactly equal to each other. But the actual terms for each row are the inverse of each other. And the reason that this works is because we never pick a max term and a min term from the same row. That wouldn't make any sense, because the min term gives us 1s, the max terms gives us 0s. So we only pick the max terms for the rows. When we're doing a max term solution, we pick all the max terms for rows that the desired output is a 0. For the min terms, we pick all the min terms for the rows where the desired output is 1. So we never would pick the same ones. We're obviously, if we pick, in this case that we're doing, let me go back here, where we're doing 0, 1, 4, 5 for the min terms, then we're going to do 2, 3, 6, 7 for the max terms, the opposites. Because if these are the ones, then these have to be the zeros, right? Now, the only thing that changes this a little bit is when we have incompletely specified tables and we have some don't cares. And we're going to talk about that at the end, but I don't want to confuse matters now. All right, so let me write these out. So it's easy for me to do it. Min term 0, I happen to know that that's always going to be, for a 3-variable problem, A prime, B prime, C prime, because it's for 0, A, B, and C are 0. For 1, A and B are 0, but C is 1. So that's going to be ORing, or plus, A prime, B prime, C. Now the C is a 1, so it's non-primed here. And then for 4, I happen to know that the A is a 1, so we'll put A, and B and C are both zeros. So that's A, B prime, C prime. And then finally for 5, that's just A, B prime, C. So there are my 4 terms. For min term 0, for min term 1, for min term 4, and for min term 5. And I can write those directly from the number of the min terms if I keep in mind it's a 3-variable problem with ABC. So I know that's true. So if I know it's ABC here, then I can just write these out down here in the expression. So this is my expansion. This is my min term expansion, or my min term expression. Now I should be able to simplify this a little bit. Okay. Now how do I do that? Well, I always use simplification theorem S3 when it comes to these things, and maybe I'll use the second distributive law or something later on, but mostly we can get all the simplification with S3. And what does that look like? Well, S3 is just xy plus xy prime equals x. We can combine these to a single term. Because the y is a non-prime here and a prime there, the y changes, so we can drop the y and just have the x. And if we have wxy plus wxy prime, the same thing. We drop the y and we get wx instead of just x. And that's kind of what we have here, right? Okay, so let's talk about this. So let's do this. So do you see any situation where we can use this theorem? We have A prime, B prime, C prime here, and we have A prime, C prime, A prime, B prime, C. The C changes. It's prime here, it's non-prime there. So we can combine these terms, we drop the C, and we get A prime, B prime. How about these two? Can we do anything with these two? We have A, B prime, C prime, and A, B prime, C. So the A stays the same, the B prime stays the same, and the C changes. So we can combine these two. And that's A, B prime. And now, the amazing thing is, we have A prime B here, B prime here, we have A, B prime. The A changes, so we can combine these and get B prime. Now, we could have done it in different order and it would have messed things up. We could have said, well, we have A prime, B prime, C here, and A, B prime, C prime here. We can combine these two, and we could have gotten B prime, C prime. But then we wouldn't have been able to combine it to get down to B prime. And now maybe we could do this. Yeah, actually we can do this. We could have combined these two into B prime, C, and then we could have combined these two into B prime as well. So either way we did it, we could have gotten to B prime. But sometimes if you do it, if you take a bad path, like we could have combined these two, and then or these two, and then we could have combined maybe this one by itself, and maybe this one and this one like we did to begin with, and we would have gotten we would have gotten a solution that wasn't the minimal solution. So when you use switching algebra, you're never absolutely confident that you're doing it in the right way to get to the optimum solution. Now in this case, I result with a B prime. I know there's nothing simpler than a B prime except the constant 1. So I know this has got to be a minimum solution. But if I got something less than that, more complicated than that, I wouldn't know for sure if I'd gotten where I needed to be. Or you might have stopped with A prime B prime plus A B prime, not seeing you could combine these, and you would have thought, well, that's my simplest solution. Well, no, it's not. You can do this and get B prime. So you're always sort of struggling with switching algebra to be confident in most cases that you actually have the simplest solution. And that's why you need other methods like a K-map or like computer-based tools. All right, and we're going to get the K-maps right after. Next week we're going to finish this up, do the test, and then we'll begin with K-maps. All right, what about the max term? Well, good question. I happen to know in this case, since I get to a single variable here, I know my max term should also get to a single variable. But let's look at it. So we have 1, 2, 3, 4 min terms. I have 1, 2, 3, 4 max terms. Let's write them down. Now these are a little harder for me to do. So I worked at it ahead of time. I'm going to take my cheat sheet here, and I'm going to just write them down. So the max term selection, I can do them from memory, but I don't want to make a mistake. And now my pen's running out of ink. So we have A plus B prime plus C, that's max term 2. And then that's times A plus B prime plus C prime, that's max term 3, times A prime plus B prime plus C. And finally, oops, yeah, I'm out of ink. Okay, let me fix that. Okay. And then it's this one, right? Okay, I forgot to turn the camera back on, so I went ahead and worked this out. Let's see, where was I? I'm not sure. So I was working on, okay, let's go back so we can keep track of what we're doing. So we're working on this truth table here, and I'm going to do the standard the min-term notation and the max-term notation. Now notice I have my ones are, I have ones for 1, 2, 4, 5, and 7. Okay? 1, 2, 4, 5, and 7. So I write my min-term notation, 1, 2, 4, 5, 7. Max-term notation is going to be the ones I'm missing, which in this case would be 0, 3, 6. 0, 3, 6. So my max term is F equals the product of the big M's, 0, 3, 6. Okay? So now I'm going to write them out. So if I write out my min-term expression, I have A prime B prime C plus A prime B C prime. That's min-term 1, min-term 2. A B prime C prime, min-term 4. A B prime C, min-term 5. And A B C, min-term 7. And now I can simplify these a couple of different ways. I can combine this term with this term, and I get B prime C. I can combine, I can't combine this term with anything. A prime B C prime, it differs by more than one variable from all these others, so I can't use my simplification theorem 3. Remember, S3 is x, y plus x, y prime equals x, right? X, yeah. So we can't use that, so we will have to, so we'll just have to leave it as it is, because we can't simplify it. But I can combine this and get BC. I'll bring down this term and get A prime B C prime, and then I can combine these two and get A B prime, and I can combine these two, which means I'm using this term twice. Totally legal. You can use the term as many times as you want. But what you cannot do is leave one of the terms out. So in this case, this term can't combine with anything, so I have to bring it down. A prime B C prime. So I have that, A B prime and AC, and now I've used at least every term once, or if I didn't use it, I brought it down. And I have 1, 2, 3, 2 variable terms, 1, 3 variable terms, and that's my solution. Okay? And here it is, B prime C plus A prime B C prime plus A B prime plus AC, and I cannot simplify this anymore. That's basically the minimum solution. Now, I wouldn't always be confident of that, except I did a K-map and looked at it, and I know that's right. All right, what about the max term? Well, here's the max term. So we'll just write that out. And so we have f of ABC. And so A plus B plus C, so that's min term 0. And then we have, this is 3, A plus B prime plus C prime. And this is 6, A prime B prime plus C. A prime plus B plus C. Now, what can I do with this? Yeah, let's see. Nothing. I'm stuck with this. This is, I think, the simplest I can do. Yeah, it is. I can't combine ABC with this because there's 2 variables different. Can't combine it with this, there's 2 variables different. Can't combine these two because they're 2 variables different. The C is C and C prime here. A is A and A prime there. That's two changes. I can't do that. I only can combine them when there's a single difference between the terms. All right, so this is my simplest. So this is simplest max, and this is simplest min. And neither one of them is real simple, but this is slightly better than this. So if you look at this, you have 1, 2, 3, 4 AND gates and 1 OR gate. So you have 5 gates. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 1, 2, 3, 4. So you have 13 inputs, and you have 2 layers. So that's the cost. 5 gates, 13 inputs, 2 layers. Here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 10, 11, 12. You have 12 inputs. You have 1, 2, 3 gates plus an overall output gate for 4 gates. So you have 4 gates, 12 inputs, 2 layers. And so it's better than the max term than the minterm solution. So in this case, I would choose this as my my simplest solution. Now, if I were going to implement it with NaNs, I still might have to use this. But if I were going to do NORs, then that might be a better choice because it's simpler. All right, let's go on to the next one. We'll just keep doing these until we knock them out. All right, so then, so we'll see here. I think I put the expression over here. Yeah, I did. You can see it's got these terms, but I didn't simplify it over here. That's just the minterm expansion, and then if I simplify it, then I got it a little simpler. Okay, so here's our next truth table. Now we have we have zeros for, well, we have ones for row. Let's see, 0, 1, 2, rows for 3, 4, 5. Okay, so my shorthand notation is going to be rows 3, 4, and 5. So let me transition on over here. Yeah, okay. So my shorthand notation then is going to be f of ABC equals the sum of the minterms, little m, would I say 3, 4, 5. 3, 4, 5. And my max terms of f ABC is going to equal the product of the big M's, and it's going to be 0, 1, 2, 6, 7. All right, so here I have 3 minterms, and I have 1, 2, 3, 4, 5 max terms. All right, since there are 8 rows, they kind of have to add up to 8 unless I have don't cares, which I don't in this problem. And then then what I'm going to do is I'm going to so I'm first going to write this expression. So I know this is, so f for the minterm expansion is going to be, or the minterm expression, either one, is going to be a b prime c prime. No, sorry, I did that completely wrong. It's a prime. Okay, I'm just starting. It's a prime bc plus a b prime c prime plus a b prime c. And can I combine anything? I can combine these two, and that gives me a b prime because the c changes. Can I combine this with anything? No. It differs by, these are all a, and this is an a prime, but that's a b, these are all b primes. So I just have to bring this down, a prime b c. So that's my optimized minterm. And if I did the max terms, then let's see what I got for that. It's going to be a fairly long expression, and I did write it down already, so let's see what we got here. Yeah, okay, so my max term expression is just going to be f equals a plus b plus c. That's my 0 max term. Then my 1 max term is going to be a plus b plus c prime, and then 2 is going to be a plus b prime plus c, and 6 is going to be a prime b prime plus c, and my last one's going to be a prime plus b prime plus c prime. Now, what can I combine? Well, I can combine these two to a prime plus b prime, and I can combine these two to b prime plus c, and I can combine these two to a plus b. Let's see if that worked out like I thought it should. 1, 2, yeah. So I have 3 terms, and these are ANDed together. And that actually turns out to be my simplest max term, but looks like the min term's better because this is 1, 2, and an output gate for 3. So 3 gates, 1, 2, 3, 4, 5, 6, 7, 7 inputs and 2 layers. And this is going to be 1, 2, 3 gates plus an output gate, 4 gates, 4 gates, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 inputs and 2 layers. So this is would be more expensive, so we would tend to choose this, depending. But maybe our target hardware is a FPGA, and it already has features in it that make it more appropriate for this solution or more appropriate for that. So that could change our mind, even though this might be simpler. Okay, okay, that's fine. And now I'm going to do one more here. We'll do the last one. So we'll click on this and bring up the last one. And there it is. So we have 1, 1, 1, 1, 1. So we have 5 ones again, and 3. So our min terms are 1, 3, 4, 5, 7. 1, 3, 4, 5, 7. Okay, let's do that. So f of a, b, c equals the sum of the min terms, little m, and what did I say? 1, 3, 4, 5, 7. 1, comma, 3, comma, 4, comma, 5, comma, 7. All right, and our max term then is just going to be equal to the product of the big M's, and that's going to be 0, comma, 2, comma, 6. Was that the same thing we had before? No, it wasn't. Yeah. Well, I think we had one of those before, though. 0, comma, 2, comma, 6. 0, 2. No, I don't think we did. Just close. No, yeah, it's close, but it's not the same. All right, so let's write this expression out. So f's going to equal, so that's min term 1. So that's going to be a prime b prime c plus a prime b c plus a b prime c prime plus a b prime c plus a b c. You should be getting able to do this now. You should be able just to write that down looking at these numbers. And then let's look about simplifying. This differs by the b prime, so we can combine these to get a prime c. What about this? This can combine, and the c is the only difference here, so we can combine these and get a b prime. And what about this? These two can combine. This could also combine with this, so we could get, in this case, the b drops, and we get a c. We could have combined this with this and gotten bc, so that's an option, but it doesn't. But either way, it doesn't really help us. Oh, wait a minute. AC and AC prime, AC and A prime C can be combined to give us C. So that gives us C plus A B prime. And then this is easy to convert to POS. I don't even have to solve this one because I know I can use the second derivative law, and I can just write C plus A quantity times C plus B prime. But let's go ahead and do this and see. So my max term solution, I have 0, that's just going to be a plus b plus c, times a plus b prime plus c, that's going to be max term 2, that's 0, that's 2. And then max term 6 is going to be a prime plus b prime plus c, that's 6. And I can combine these two to b prime plus c, and I can combine these two to a plus c. And that's what I got there. Well, switched around. A plus c and b prime plus c. All right, so it checks out. But it turns out that's our minimum solution with 2 gates and 1, 2, 3, 4 inputs and 2 layers. Whereas this has 3 gates and 1, 2, 3, 4, 5, 6 inputs and 2 layers. So clearly the SOP is worse, so we would pick the POS is worse, so we would pick the SOP. All right. Now I'm going to talk briefly about the incompletely specified. Let's see. Let me go back to do this. Okay. So what I want to say is I think I'm going to cut this because I'm already at 34 minutes. I wanted to make it fairly short. Mostly just give you practice with these min terms, max terms. I want you to have this down. I want you to know what you're doing. But if we have an incompletely specified function, let me show you how we write that. Let's go back and say we'll take one of these truth tables, and let's put, say, we'll do this one, and let's see, can I fix this? Oh no, I can't. I have to shrink it down. Okay, sorry. Let me do this. Let me go over here and fix it. Okay, now you can see I have a don't care here, and so I have minterm 1, 4, 5, and 7, and a don't care for minterm 3. So how would I write that? And I'll write both expressions. So the minterms are 1, 4, 5, 7. 1, 4, 5, 7. All right, let's do that. So we'll switch over here and hopefully get this going. Hang on. Oh yeah, sorry. All right. Okay. So so it's f of ABC equals the sum of the little m's, and I think I said it's 1, 4, 5, 7. 1, 4, 5, 7. And then what about the don't care? Well, we do plus the don't care, the little d, and we do that don't care. In the don't care, in this case, we put it 3. Now the max term, we would do f a b c equals the product of the max terms 0, 2, 6 plus the don't care 3. Only in this case we'd use a capital D to indicate it's a max term. So in this case we would choose the don't care. Our x would equal 0, and here our x would equal 1 if we add this term. But if we add this term in the max term, then we have to make the x, we have to consider it to be 0. If we add this one, we would basically consider it to be 1. The reason, though, it doesn't really matter is that our customer told us that the combination for 3, which would be a equals 0, b equals 1, c equals 1, will never happen. Never happen. So since it never happens, it doesn't matter what output it would have produced. That will never occur. So we'll just pick whatever we want. Since it's never going to occur, it doesn't really matter. And so that makes it a don't care. And don't cares are really helpful because they help us to simplify it. Now with switching algebra, this is difficult because with switching algebra, we have to write two solutions. We have to write one solution where we have, say in the midterms, 1, 4, 5, and 7. We have to write another solution where we have 1, 3, 4, 5, and 7. And we already solved this, but I'm going to do a little K-map, and I'll show you how this works on the K-map. So on the K-map, it's really nice. So we put in the 1, so we have a 1 here. So this is box 0, 1, 2, 3, 4, 5, 6, and 7. So we have a 1 for here. We have a 1 for 4, and 5, and 7. And if we also had a 1 for 3, so here's our don't care. Now we can pick that. Well, it turns out if that equals a 1, we can group these boxes, and then we'll have this little group, and we'll have, that will give us the answer we found before. C plus A B prime. And in the max term solution, we could write that A plus C quantity times A plus B prime. And we want to take this as a 1 in both cases. That would simplify it. Because our max term solution is just this group of 2 zeros and this group of 2 zeros, a wraparound. All right, well, enough of that. Just to whet your appetite a little bit for the K-map. So I think with that, I'm going to stop the recording at this point. So what I want you to do is play this and make sure you can solve all 4 of these truth tables. You can write the min term and the max term notations. You can write the min term and the max term expressions, and you can simplify them. Okay? But you'll see when we get to K-maps how much nicer K-maps make this process. All right. Okay. So we'll do that, and we'll see you with a recording on Monday. And maybe what I'll do on Wednesday next week, maybe I'll go ahead and show up to class. Maybe I'll have everybody come into class on Wednesday, and we'll do a review to get you ready for the test on Friday. So you can think about that. If there's strong feelings about having the review in person or on video, let me know. I'll do it either way. But if you want to come in and have a face-to-face review session on Wednesday, we can do that. All right.